Problem 1.82. In this problem, oil, which has a viscosity of 0.0003 pounds per times seconds per feet square and a density of 50 pound mass per feet cube, flows in the boundary layer shown in the figure below. The plate has 1 foot wide perpendicular to the paper. The goal of the problem is to calculate the shear stress at the plate surface. For this problem, we are going to assume that the liquid is a Newtonian fluid. We're also going to take it as an steady state conditions. And in this case, notice that the velocity is given to us, so we cannot assume that the velocity is linear. We're asked to calculate the shear stress at the surface. So we define shear stress as the viscosity times the rate of shear strain. So we take the velocity. So we have it as 15y minus 5e to the sixth y to the third, and then we take the derivative of this. We set du dy, and then the derivative of 1500y is simply 1500, and then the derivative of this is 3 times 5 to the sixth y squared. Since we are evaluating this quantity at the shear stress at the surface, we evaluate everything at y equal to 0. So we substitute y equal to 0, and it gives us that the u dy, we don't have y over here, so it's 1500. And then this component over here is going to be 0. So it's basically it's basically 1500. If we keep track of the units, notice that we have over here that it is feet per second. We divide it by feet since we're taking the derivative, so the unit of this is equal to 1 over second per the equation given. We substitute into here, we have that the value of shear stress evaluated is going to be equal to 0.0003 pound per second feet square, and we multiply it by the rate of shear strain, which is 1500, and we have the unit of that to be 1 per second. So notice that the second and the second cancels, and then the value of tau becomes 0.45, and the units left are pounds per feet square, and notice that is exactly the units of shear strain. The direction of the shear strain is always the opposite to the flow, so this flow is going from left to right, therefore the shear stress is going in the opposite direction.